second installment, creating the interviewer startup idea. In the first one, we created the UI, React UI, but it was hitting using mock APIs. So and it wasn't hooked up to the AI at all. And we created the repository, and we validated the idea using gstack, and focused on what our B0 should look like, 0.1, whatever you want to call it. So in this one, just like the first, I don't have a real specific plan on how we're going to go ahead and build it, but the goal is the front end we'll call a well-engineered backend. It will be secure, and it will use an actual LLM call and return the response. So let's get cracking. Okay, so we are working on our project. It's project. That's right. Got a name. Project log. Next step is to build the backend. So that's going to be .NET 10 APIs. So look at what we've created in the front end, check the documentation, and create APIs in the .NET project, and do some research. Take some time to do some research for what is best practice for those .NET 10 APIs, so that they are structured correctly using modern techniques, including keeping them secure. Ask questions if you need to. For now, just stub them. We'll put the implementation after. We'll complete the implementation after we've hooked it up. So I suspect that should then go ahead and create a C# project. It might ask some questions. We'll wait and see. But it should be a fairly basic. This is a fairly basic ask, hooking up some endpoints that the front end needs, and just simply stubbing it. So I don't think this will be difficult for it. So it's good. It looks like it's going to create some OpenAPI, which is, for those that are familiar, a word is Swagger is the old name. Just it's like documentation for the API. So it has enough structure to proceed. So it's going ahead and building things. Should see some changes over here. It's created the settings, just your normal basic one, but also development one where we can put some secrets potentially. Interviewer API and basic program. It's still got the weather forecasting default in there, and some launch settings. It'll be running on the port 5192. So nothing, and it's just created a whole bunch of extra stuff. Just let that continue to cook. Oh, and it's going to be doing the in-memory cache. That's going to be handled on the back end, which would be expected. Good. So that has finished, and it's created those API endpoints and some DTOs by the looks of it in the changes. I noticed as it was working that there was a whole bunch of files here that were not the kind of files that you'd want to commit to source control. And Codex noticed that as well and has created the git ignore file and is ignoring all those noisy files. So these are just ones that we care about. So I thought that was nice. And it's updated our documentation as we've been using as we're going through with our new details. I presume we might have a few ticks now or crosses to say that's been done, including the technology plan. Just got the details of what has been added. So there's good documentation happening as we proceed. The project structure looks a bit like, well, we've just got an API and the web. So there's no tests at all. So I might just chuck that in next. But before I do, I just want to add, this is v1 API added. So we're moving very quickly with the commits and check-ins and code reviews because what I want is a functional system, and I'll lightly review the code as we go through, and if I see any issues, then we'll address it when we hit them. And what the first issue is, we don't have any unit tests. I didn't ask it to create unit tests, so that will be why we don't have any. Great. There aren't any unit tests, so create a interviewer.tests project and reference the API project from there and write some basic tests to get us started. So we'll use that one tests project. This is a brand new overall project, brand new repo. What I tend to do with something that's so new is have just the one tests project. You can just run all your tests from there. As the project grows, becomes a bit more unmanageable, you have more people working on it in different teams potentially, then you might want to start to split things out so that different modules within your application have their own tests project file. But this early on, it's better that we keep it in the one. I also, at this stage of a project, only work on the one branch. It's just me. Again, if there was multiple people working on it, that would be different. The other thing is, at this early stage of a project, I think it's best to build it as a monolith in a modular way, so that when the project becomes bigger and it's running in production and you start to see pressure points, either working within the development team or with performance when they're running in the cloud, that's when you would start to look at creating isolated, contained services, pulling out those services so they can be deployed on their own and obviously run on their own as well. So yeah, so that's now finished. And so we've got some basic tests. Have a sneak peek at what sort of tests we've got. Okay, that's a good starting point. It's also noted that we've got that there now, so just leverage the little button, see what that has to say. Oh, it's xUnit tests. Now, I personally prefer NUnit, but one of the things we're doing with this video series is leaning into services or tools, technologies that I'm not particularly familiar with, because it shouldn't, my familiarity shouldn't matter too much with the specific tool. The general testing, in this case, the general knowledge of what a good unit test looks like, that's very helpful. The underlying tool doesn't matter so much. So I'm going to stick with that. and keep all of these tests as xUnit tests. Next thing, let's get the front end to call the back end. Great. Now get the React front end to call the back end APIs, so that when we then run it and confirm that it works, confirm that the calls are received in the API. Now, one way that you might want to do that, or maybe it doesn't matter anyway, we need to add logging. So add Serilog to the API project. No, I'm going to back up one step there because I want to put Serilog into a more base type project. To add the logging, I want to do that via a common library. So add a new interviewer common project that will be most other projects will reference this, so we'll keep the references that it has to a minimum. But we want to add a reference to Serilog in that project. And then obviously from the APIs project and the test project, add in a reference to the common library. For now, it's just a Serilog setup, and add the Serilog configuration setup code to that common library in a whatever the best practice is, but I think maybe a static class that can be with a static method that can be called. So that's going to give us the foundations for logging, which is obviously crucial for any system when it's running, but it's also extra crucial once we get it running in the cloud, that we can diagnose what's going on when problems occur. And we can also use those logs, obviously, to confirm that, oh, yep, everything's working as expected. Right, we'll just let that cook to the point where it looks like it's both runtime processes are listening. It's using the browser automation pass against the React page now, and then it's going to check the logs. It's checking if Playwright is available. We can add Playwright if it needs it. I'll let it finish what it's doing though. Oh, Playwright is available. I'm using it to run the setup. And to import the flow on there. Okay, excellent. So it's working away. This is the code it's added. So that has the reference to our new common project. It's our new common project, which will have the Serilog extension. It's only got a console sync, so we'll add a debug sync as well. But console's probably the main one. And that's a basic setup for Serilog. It's fixed up the port to look at a real port. Okay, so yeah, it's all looking pretty good. What's it doing? Okay, it's still working away, testing. Just thought of something else I want to add whilst that one's working away. Create a README file by taking a quick look at the code that we already have, but also there's a project markdown file, which shows what we've done and what we're going to do. So write the README so that it reads well for what this project is for. Didn't feel like I worded that particularly well. Target audience is obviously developers. Okay. So you can obviously kick off as many of those as you want at the same time. The only caution I would say is I'm always working on the same branch here, because then I don't have to mess around with any merging issues. So if you're kicking off multiple agents to modify files, if they're working on the same files or potentially going to work on the same file, they can sort of step on each other's toes. They're not too bad at figuring out that something else has made a change, but there has been a couple of cases where I've had one instance update the code from another instance. Very rare, but just if you're going to kick off multiple agents, make sure it's in a different part of the system. So kicking off a README file is obviously going to be very safe. Project log hasn't written it's still busy working away on the README. Still going. Okay, how's this looking with the testing? Still working away. Okay. So implemented, that's the changes. Drove the React UI through setup and answer and report generation there. Confirm those posts. Confirm the API Serilog, receive those calls. So as far as it's concerned, it works and talks to the backend service. So we'll want to test that manually ourselves as well, just to see it working. That's the README file, so we've got that there. So this is what we'll see now in GitHub. Once I push this up, it shows our current status, privacy model, project layout, tech stack we're currently using, how to get started. So all the useful stuff that you'd expect in a README file. And that I said the target audience was developers, and that's true, but the target audience actually is also agents. But if it's readable by developers, then obviously it's very readable by agents. So nice. I'm happy to just commit that. Now we'll probably find some bugs, and when we do, we can see those fixes getting applied. So that's for me, it's really important to do this regular check-in. It allows you to keep on top of all the changes that are happening because they come fast. Okay, so the front end should be talking to the back end. We punch in some information into here and hit go. Something should happen, and it's giving a server error when we make a call to the API. So we need to see the logs for the server. What I would normally do here is I'd fire up Visual Studio, run the API from there, and because then I have familiar debugging tools, and obviously I can see the logs. So, but that's a great way to do it. For this, I'm trying new things. So I'm going to try and avoid having to use that because maybe not everyone has access to Visual Studio. So what I'm going to do to give me visibility of those logs is add Aspire, because it has some observability that makes it really easy to see the logs across multiple services. We've only got the one service, but there could be more in the future. So hook up the .NET API to Aspire so that we can see the logging, etc., of the observability metrics in the Aspire dashboard when we run it. That's working away, adding it in. I just noticed as well that I've made this request on the README chat, not on the chat that we were on before. And it's obviously proceeding without a problem, but it might not be aware of the working document. We'll see if it updates it when it finishes. It's updating the README file. So I'll just tell it. We also have a project markdown, like working document. Make sure you update that with this alteration as well. That'll do. Oh, I might bump that up to high. I tend to like working on high unless it's a relatively simple task. Okay, so we'll just stack that so it's ready to go once it finishes with the changes. So it's added a new app host project, which is kind of how Aspire works, and a service defaults. Yep, so that's what I'm expecting to see. Cool. Project log. I always forget the name of it because it's different in each project, but project log, it's updated that with Aspire now. And the technology plan, obviously. Excellent. So it's doing a great job. I don't need that steer anymore. It figured it out. I'll pause until that's done. Okay, so that's just finished off. That is the command, the .NET command to run it. It's updated all the docs. It would have built it and potentially run the unit tests as well. But that's pretty minimal tests there right now. So I'm not sure if it's actively running right now. Aspire. You can just grab that and test. Let's go on this side. No, okay. So open up the terminal and oops, wrong one. Okay. There we go. No, there's an error. Well, that says the status is okay there. What failed? Okay. So as a key repository, service access denied. Can you see the open terminal and the error that's in there when I ran this command? It's a bit of a weird error because access denied in Win32. Something odd. Probably something was already running. If not, I can cut and paste it for you. It generally does have access to the terminal, but sometimes it has trouble getting it. I can't see it from here. Okay, well, let's just grab that. Grab the whole stack there, and you know where that opened up. Oh, okay. So then it's going to help me figure out what the problem is, and I'm pretty sure that it's probably something to do with a running instance. So that's the API health. I don't want to hit the API health. I want to get to the dashboard. What's the dashboard like? Enter a token to log in. Oh, okay. Interesting. That's the token there that it's saying that we need. I haven't seen this before. I've worked with Aspire before. Maybe this is a new version or something. So that's Aspire, that's our service. If there was multiple services running, they'd all be showing here. And you can view the logs there, and that's going to be, that's for our API. So that, let's see if we can, if it shows it dynamically. Let's just try this again. And there's our error. No, there's some logging, but no error. I was expecting to see a 500 because that's what the front end is getting. Oh no. It didn't get an error. That's why. Okay. whatever the problem was has gone away, and it's asking me to tell the story of this. Now we're still not hooked up to the LLM, so now the front end is talking to the back end, and we can see some logs. Now I want to hook up the actual LLM call, which is, there's a fair bit to that, because I want to configure it to be, because it's an open source project, I want it to be configurable for Google Cloud or Azure or potentially AWS. To keep it shorter, I'm probably just going to do Google Cloud and Azure for now, because I've solved those two previously. So I'm just going to close this down for now. Leave that. Okay, so that's all good. Might go to a new chat. Okay, so our project log, just putting it there as a point of reference that it needs to be aware of. It's defaulting to medium. Let's get it up to high. The front end's now talking to the back end, but I'm pretty sure we haven't hooked up a call to a live LLM yet. Well, I'm certain, actually. So that's the next step to complete. If that's not already in the log, the task list, let's add it there explicitly, and let's make that happen now, so that when the request comes in, it gets processed by an LLM, which gives us a live response. Now, to talk to the LLM from .NET, Semantic Kernel is what I've used in the past. And that enables it, that just makes it easier to swap out different models, etc. So this is a problem that I've solved before. And to get a better result, I'm going to tell Codex to refer to a different repository where I have solved this before, so it can get an idea. And I'm also going to tell it to use to do some research for best practices, because best practices change rapidly for AI. It does feel a little bit like cheating, because the idea of these videos is to build something from scratch. However, when you are building something from scratch, if you're a developer, you've probably solved many different problems before, and it's a good strategy to point the AI at a project that has that solution, which may not be a perfect fit for this particular project that you're working on. But it's a good reference point when you're happy with how that was solved in that project. So I'm just going to show you what that looks like, because I think it's a good strategy when you're building a system to leverage learnings from previous projects. So take a look at this at the directory below. It's a repository where I've connected to LLMs. So there's a real config system which allows for different providers connecting to different providers, both Google Cloud and Azure Foundry. So leverage learnings from there, and you can take those patterns and apply them in this project. One thing that I want you to do as well is to look at the project structure, because I don't want all of this business logic and configuration logic all living in the web project. Let's create an AI project, interviewer AI, and potentially other reference projects. Again, look at that repository and determine best practices. So that's the configuration for the LLM to call, but then also how do we, actually, no, let's solve that problem first. Then we'll solve the problem with the semantic kernel and actually calling the LLM. Now I can probably just delete part of what I just said because I changed my mind mid-talk, mid-command. But then also how do we, yeah, okay. Oh, I didn't tell it the folder. So I will stop that once it starts. A bit sluggish there. Forgot to give you the folder. Here it is. And see. Helpful if you provide the reference you said to look at. Okay, it's going to take some time to go and review and pull those in. Oh, I forgot to commit these changes. I'll just stage it. Don't think it's going to be making any changes too quickly. And put that on. So that was adding Aspire. I hope that's in the comment here somewhere. Add Aspire at host and a few details about that. A bit more noisy than we need, but that's good enough for a commit comment. All right, so again, I'll just let that cook because it's going to take probably 15 minutes, 15, 20 minutes, maybe a bit faster because I've got the speed on. And we'll jump back on once that's done. It was only about 5 minutes. I mean, it hasn't finished, but it looks like it's getting close to done. Configuration model, updated the technology plan. It's got our new project, and within that, different AI models, configuration. So this is the AI models can come through here. You can configure different deployments that you've set up in the Azure Foundry or Google Vertex AI. We will actually configure real deployments, but not right now. Okay, so that's a new project. We've got it references the tests. Looks like there's some LLM deployment catalog tests. Checking some things. Excellent. So yeah, working through. The build is clean, and okay, tests pass. Okay, so that's done, and looks fine. We won't. The way to test it is to create an actual deployment and get a successful response back. This strategy is a bit different to what we talked about in the first video, where we're going to configure our own connection to use our own API keys. So the provider of the service is doing that. In the first video, I suggested that users should bring their own API key, but then I was thinking about that, and I don't want to encourage people to do that. I wouldn't encourage someone to put their API key for AI into a service for a probably unknown provider, because you just don't know exactly how they're going to use that. So that seemed like it was a dangerous strategy, so we'll need to remove it. But I haven't actually changed that strategy in our project log, so I'm going to do that now. So I think in the project log, we've got a strategy for the user of the system to provide their own API key. But I now believe that that's dangerous. So let's remove that from the front end. That's the only place it would have been implemented. We've just done some work for the back end for the provider of the service to set up their own AI configuration and their own keys. That's how the service should work. So yes, go just fix up the front end and change the documentation to reflect the fact that users definitely should not be providing their own API keys. So I'll stage those changes. I stage those changes in case this work starts making changes to files before I do the actual commit. Okay, which is pretty unlikely because I was just ready to click the click commit button. So yeah, I think that's a much safer strategy. We don't want to be encouraging people to pass their keys around. Okay, that's fixed up now. I guess it's dropped off the form, so there's no longer an area for them to provide a key. So that's much safer. That original decision wasn't smart. So I'm just going to commit that. And so the next thing, we now need to configure talking to an LLM. And the way we can, there's a few providers we can use. I'm going to use Azure to get the model. But whichever cloud provider you're using, it doesn't matter. There's a way to get it set up. And with the configuration we just added, you can also connect to Google Vertex AI. Relatively easily, you just need the URL, the endpoint, and an API key. Maybe a few other details. I can't remember the specifics. So okay, so let's just have a look. So you can essentially set that up in Azure via the Azure Foundry. And 6 months ago, I would have come in here and I would have manually added the deployment, and I would have then grabbed the API key with the endpoint. But I'm not going to do that because the whole point of these videos is we're using Codex to do pretty much everything for us. Now, if it's going to do something within Azure, it needs permissions to do that. So first of all, your account needs to have the relevant permissions to create and update the things that we're going to create. If it doesn't, and your organization doesn't allow it, probably best not to push for it. There's good reasons for those sort of security controls. If you're doing a home project, you probably do have the ability to do that with your account. But obviously exercise as much caution as as you feel comfortable with. So for me, I'm pretty confident that it's going to do the right thing for me, and I don't think I'm logged in. So I'm just AZ account show. Make it a little bit big. So yeah, so we've got to log in. So AZ. This is logging in to Azure. I think it's this, and then I've got access to multiple different Azure instances, so I'm telling it which one I want to connect to. Otherwise, it'll probably connect to the wrong one. It's giving me a browser window, picking the right account, and then it says, "Yep, you're logged in and authenticated," which you can see here. And then I just pick the subscription that I'm connecting to, and then we now have we're now logged in. Now that I'm logged in, Codex can reuse my permissions. So that's another thing to be aware of. If you don't want Codex to reuse your permissions, maybe log out first. Okay, so I'm just going to ditch that. Great. The next thing we need to do is to set up a deployment in Azure Foundry. Let's use GPT 5.4 Mini as a deployment. So do you have access to set that up for me? Let me know if you don't, and what permissions you need if you do not have what you require. Use best practices for any naming conventions, for any names that you need to create things, not just generic things. So it needs to be clearly associated with the interviewer project. So the other thing is, once that is created within Azure, I can then get it to add to the configuration. for my entire development career, you'd set up these things manually, maybe with infrastructure as code, depending what it is. Then you'd grab the configuration details from the portal of whatever it is you're setting up. So the Azure Foundry, for example, and then drop that into your configuration. Make sure your config is set up to add all of those details with the secrets in the developer secrets file, or perhaps the development file. Okay, so I'm authenticated to Azure and it's telling me who I'm authenticated as and which subscription it's on. So I've only got the one subscription. Okay, that finished. So it's set up the Azure resources. I'll bring this over from here. We can see our interviewer AI. I didn't create anything myself in Azure. So that'll be my API key and the endpoint. That's a subscription as part of. And so it's in East US 2. I didn't specify where, so I'm not sure if that was something I could choose. Happy to leave that where it is for now, though. Succeeded endpoint. Didn't print or store anything. Did it change anything here? No. Great. Now update the configuration for the API so that it uses the new endpoint and store the API key in the developer secrets. So yeah, like I was saying before, normally I would have cut and paste this into my config file, set up the configuration so that it, I had a place to put it, run the .NET command to add the secret. But I can just get Codex to go and do all that for me while I go make a cup of tea. That's great. Once that's done, what's left for us to connect or set up so that when I click the start mock interview button from the UI and which passes in all the details, that then makes a call to the LLM and sends a response back to the front end. Okay, so that's added these developer secrets. It's put this information into the development .json, which is definitely right for an open source project. I don't want everyone hitting my endpoint. Not that it will work without the key. And the key would have been put into my secrets file. Cool. And it's using the interviewer ChatGPT. Nice. And I guess, so yes, you can see it's set up the secrets for the project and it would have updated the file as well. So we can commit those. Just quickly add it to staging because this is working. Oh, no, it's not working. I didn't hit go. It's always helpful to hit go. We've got plenty of room and tokens. All right, I might just let that give us the answer and then come back. Okay, front end's already basically the right shape. What's left is back-end wiring. Yes, we didn't do our semantic kernel. Implement the real workflow. Okay, make the necessary changes to the back end. Make sure you're following our project log and keeping that updated with changes. Let me know if you have any questions, if something is not clear. But beyond that, just keep working until you're done. Make sure there are unit tests for our changes. And done looks like clicking that button, the start mock interview from the front end. That makes a call to the API, which then calls the LLM and ultimately returns a response back to the UI. So I'm happy with the list of outstanding tasks. It makes sense to me. We're still just keeping this the state in a session. So we're not persisting anything at this stage, keeping everything really simple. It says it's done. Backend now calls Azure Foundry when the UI starts a mock interview. Tells us what changed. There's unit tests, and it's updated our working docs. Okay, all right. I would normally spend a bit more time reading these a bit more thoroughly, but in the interest of making the video move rapidly, just very quickly flicking through it. LM chat client, it's created a new class. Fixed an API endpoint, it seems. Workflows, a new one. I'm kind of expecting it to use Semantic Kernel, but I'm not seeing it being added to the project file. Just a quick question. Does it use Semantic Kernel? I can't see a reference to Semantic Kernel. Let me just double check that myself manually. So it's probably in the API project, and we would see it in the project file. There would be a reference. So we're actually referencing the OpenAPI package. So we're not quite finished because I want to use Semantic Kernel because it means that is like a wrapper around. It's not a wrapper around anything. It allows you to just use the Semantic Kernel, and then from there you can call lots of different providers rather than adding the a package for each of those individual providers that you might be wanting to hit. If you're wanting to hit just one provider and you know that's all you're ever going to want, then by all means add that. So now I've checked this myself. I'm just going to give it new instructions. I noticed that we're using the OpenAPI package directly. Change that so that we're using Semantic Kernel. Do a little bit of research on what is the current best practice for the Semantic Kernel. Also take a sneak peek at the RollSage repo. I can give you the path for that if it's not in your memory. And because there's some good practices that are being applied there. Now it'll probably work if we provided the information. Now it's going to do some research, so maybe we can get that working. I'll just grab some details into my clipboard. Okay, yeah, I wasn't fast enough. It started making backend changes before I got all that sorted out. So it's finished. It's made the semantic kernel switch. We've got some semantic kernel code. And in the AI project, it's referencing semantic kernel. If you're not familiar with semantic kernel and you work with .NET, then take a look at that. Do a bit of research. Okay, so I don't remember. Give me the command to run the Aspire. Not the best English, but it understands me. No, don't need a secret list. Just need that. I could ask it to run it, but in this case, I decided to do it differently. Okay, so that's doing that. Does it have a specific port? Couldn't copy. It's not liking that. The build failed. Couldn't copy. I think we might need to restart something. Just going to put these changes in. looks like it's blocked by another process. So maybe restarting this will help, but the process might not be associated with this, with Codex. So it's hard to say. When I tried to run it, I'm getting can't access file type error. Can you build and run it and kill any processes? Ooh, no, maybe not. See if you're able to build and run it in the sandbox or whatever, somewhere that's able, the front end is able to reach it. Because when it runs it runs it in its own console, potentially in its own sandbox, and it will have access to the output and can work through any problems that it finds. That it's a file lock, and it's currently it's probably our previous running service because the health endpoint is returning healthy. Okay, so yeah, fixing it up, starting again. Okay, so our old interviewer process was still running, which is now stopped and restarted. So this is our Aspire dashboard. Don't want it to open there. And we're going to need this token here. Okay. And link. See that? Go straight. Didn't need that thing. Oops, I clicked the wrong button because that's an API. So, okay, yep, the API is running, so we can watch what's going on over there. Let's try adding in. I've added in some details over here. I tried it before and it failed, so let's just give that a click and see. We should see a call come over here. Let's come back with a question. I can't really tell. Endpoints received, interview session start request. Okay, great. Now I can't really tell when a call is made through the LLM. So add some extra logging. That includes timing because I'm curious about timing. And if the response includes any token usage information, then log that as well. And once you've made those changes, stop the existing running Aspire services and start up the new build. So it's still working, but it's made those changes, and the new Aspire instance is running. It's checking that it's healthy. A couple of significant changes there. Mostly a lot of logging info that we're going to see now. That's really helpful, and probably some tests around the logging happening. Cool, great. So I wonder if I want to go back and ask the question again. So there we go. Go ahead. Here's one. Story. Okay. And it's not actually running. Not change port. Yeah. Great. Can we set it up so that we don't change the port every time? Let's pick a persistent port to always use for our backend service, and front end for that matter as well. Should be its own port, but always the same one. So that's where we're at. And we should be able to see go, and then we'll get some logs. Semantic kernel chat completed. There we go. Mini chat. Response length 282. So it's calling. It's working. So that's Great, and that's the response. Whether it's a good one, not up for debate right now. So that's the final change that we'll do for this video. It's now, the front end's now talking to the back end, and the back end is talking to an AI provider, which in this case is the Azure Foundry. And we've got some logging so we can see what's going on. In the next video, we'll deploy it. We'll set up a CI/CD pipeline in GitHub. So GitHub Actions with the workflow, and we'll deploy it to Google. Well, since we're already in Azure, we'll deploy it to Azure first, I suppose. And no, we'll deploy it to Google Cloud. And we use Terraform as infrastructure as code because we don't create anything manually these days. But you want a consistent way to do it. Like I would never ask the AI agent to go ahead and just create some resources for me in a cloud provider. I would always get it to create some infrastructure as code so that I can get that right, and it then is repeatable. So that's what we're going to do in the next video. Thanks for watching.